It's time. The potential of data and AI is too big. And the problems we're solving are too important for it to be so hard. It's time to set your data up for success. Time to let it drive, because data is all grown up now, but we still haven't taken the training wheels off. It's time to be open, to unlock, unlimit, and unleash data. It's time to work together as data teams, as a data community. Innovation doesn't happen in isolation, because when we're united, we do what teams do best. Above all else, it's time to simplify. One place for all your data. One foundation for every workload, from BI to AI. One platform that runs where you run. One architecture that puts an end to the trade-offs and brings it all together. One Lakehouse. Databricks helps data teams innovate faster on the world's first and only Lakehouse in the cloud. Open, simple, collaborative. Now you can have it all your data, all your analytics and AI, all your data teams. One platform for today and in the future. It's time for Databricks.
Right, and very welcome to join this session on Azure Databricks Essentials. My name is Hao Wang. I'm a Partner Solutions Architect based in Singapore. And together with our colleagues Joey and JK, we'll be answering your questions in the Q&A portal. We'll be spending the next hours together, right? But first of all, a few housekeeping items. So on this platform of the live broadcasting system, you should be able to see all of these kind of components, right? So make sure that you use this Q&A channel to ask your questions along the session, because this is just 1 hour, so ask your question early to get it resolved, right? So you can also resize all of these by or to maximize each of the components. So the agenda for today in the next 1 hour will be 2 parts, right? So in the first part, we'll be talking about in slides for 25 minutes on what is Lakehouse and what is Delta. Also, we'll be introducing end-to-end machine learning on Azure Databricks. Then today's session will be very heavy on demos. Will be like 35 minutes on that. You can see a lot of components there. We'll first give a tour in Databricks workspace, then we'll be seeing how streaming workloads is used together with Delta tables. Also with the autoloader to ingest your JSON files into the Delta tables. Then we'll be looking at the simple integration with event hubs on Azure, as well as integration work with Azure Data Factory. We'll be closing it by having a more thorough demo on machine learning from model development to serving on Databricks. And we'll be closing it by having a short tour on Databricks SQL. You can pretty much go to this link if I can have JK's help to broadcast this link to the Q&A session and send you all. That would be great. But this will be all the content shared in today's demo part, right? So without further ado, let's jump into the first part. So on the screen, you will see 2 parts, right? Data lake and data warehouses. So if we're saying Databricks only have 1 product to sell, that will be the Lakehouse. So what Lakehouse is to combine the benefits from both of the worlds of data lake and the data warehouse to provide you with a single platform for all of your data and analytics and AI workloads. So Lakehouse is pretty much a concept, and this is the architecture that we're pushing for all customers to adopt for all the use cases. And the projects driven behind it, or you can use to build Lakehouse, is called Delta Lake. So Delta Lake is also an open source tool for you to build all of these Delta tables to form your Lakehouse. So just imagining you have a bunch of Delta tables, that is pretty much your Lakehouse architecture. So what Delta brings to the table is pretty much better reliability with the ACID transaction capabilities and much faster data processing with smart indexing, as well as it brings to the table a full system of data governance as well as access control. So if we look through today's modern data and analytics needs, everything will start from the bottom, from your data sources. Data sources can be in various kind of form, right? From different kind of structured, unstructured, semi-structured data sources to different volumes and different speed. And all of these, we would recommend customers to put in the raw data layer, for example, in your AWS cloud storage. And then we should do some curation on top of the raw data to create the tables on top of them, right? So after we have created all of those tables, we're ready to consume that. The method of consumption comes in different flavor as well. For example, you can do data engineering and streaming workload mounted onto your tables. You should also be able to do DS and machine learning work on that. Of course, don't forget that you have a team of BI users, for example, your business analysts, who are ready to consume your tables to do reports and then to do the analysis from there. Right? So all of these are the personas in all the enterprises, the data teams, breaking down into like 3 types of user groups. So with that architecture in mind, having the right foundation is really the key to success. So pretty much if you see all the components here on Azure ecosystem, you'll be seeing this as a complete picture, right? So again, we start from bottom with all different kinds of data coming into the cloud. Then you can put them into the cloud storage like AWS. Then we'll be pushing for the Delta tables to make your Delta tables to form a Lakehouse. And after you have a bunch of tables ready, you are able to consume them from different points, right? For example, you can create tables directly in Databricks, and you can consume them in some peripheral Azure services as well. So having this right foundation enables you to handle data of different size, different type, and coming at different speed. And remember that Delta, as an open source project, this will be an open format, means there's no vendor locking, right? And having Delta, this is also supported by many major Azure data services. And later on, you will see like how Delta brings the capabilities to deal with ACID transaction and also data versioning, and also providing you with all the audit histories. All of these are built-in features once you start using Delta. So let's zoom in a little bit on how to create a Lakehouse and all the Delta tables there. Right? In Databricks, we always push for this simple architecture with proven record for all the kind of data use cases. By having all the green box here that we can look through one by one. So for example, everything that we have stored in the AWS or the cloud storage, you can process them and then to create the Delta table on top of it. Right? So this is called like data ingestion there. Then you can have 3 components within Databricks workspaces. Note that these are dedicated places for people to work, to create their work. Right? So for example, your data engineering and streaming task, or your machine learning workspace, and also your Databricks SQL Analytics tab that will be taking a deeper look in the demo. And also, as a unified analytics platform, Databricks also provides this collaborative environment for users to work together, right? And now your data engineers will know like each other's work, and data scientists can come and see how data engineers are creating all the tables. And all of this will be based on single source of truth of all the data, since you have your all the source data ingested in your AWS in the first place. Right? So at this moment, we definitely would have this question, like why we are pushing for like Delta Lake, why we should be using Delta Lake. Right? So the high-level answer or the summary will be using Delta Lake, you'll be having reliability, you'll having performance boost, as well as governance and quality for the existing data lakes. And Delta Lake, if you zoom in to the underlying storage of the data, you'll see that the data are still stored in the open format, in Parquet format. Right? It's just like we're adding in the transactional layer, transaction histories together with the data. So having Delta also simplifies the whole data engineering approach, because we are pushing for a curated approach to do your all the data lake tables. Like described here in this medallion approach, we have this bronze, silver, gold layer concept, where bronze is more like you have your data sources ingest into Delta table in the first place, and this will be your single source of truth for all of your enterprise's data. After you have done some curation, some cleaning or filtering, you'll be creating all those silver tables, intermediary tables. Then you'll be creating your consumption layer, which we often refer to as gold tables. These often are the business level aggregates that's ready for the downstream consumptions, like your BI users or your data scientists, right? So all of these are the existing limitations that if you are using Parquet-based tables or other format that's common in the traditional kind of data lakes, right? So if you're using Parquet-based tables, you'll pretty much face all of these three types of issues. Like within your ingestion process, you'll be finding that if I want to modify the existing data, that's quite hard. You have to reload that in and then to do some changes and then to write it back to somewhere else. Also, to incrementally processing your tables or data is also difficult. Not to say that if you have streaming use cases continuously writing out to the table, that will be hard as well. Right? You need to write your own ETL pipelines to do this kind of incremental processing. In terms of performance, using Parquet, you often will see this too many small file problem. Very obvious in the streaming applications, and also some poor indexing issues will happen if you use Parquet-based tables. Also, in terms of reliability and data quality, there's pretty much no built-in kind of quality control on the Parquet-based tables. Not to say that you cannot do like data versioning and you don't even have the audit history if you are keep with the Parquet-based table. So Delta pretty much comes here to solve all of these listed issues, right? So by having the detailed solutions on the right, you can see Delta have the built-in ACID transaction. It also has the built-in incremental process and CDC process between the Delta tables, making things much easier. Also, you can mount your streaming and batch operations together onto the same Delta table, which makes things much easier as well. In terms of performance, Delta brings to the table many features like the auto-optimize, auto-compaction on the file level. This is to merge all your underlying small files together into bigger ones, so to increase the performance by a lot. Delta also brings this automatic indexing as well as the ordering and data skipping capabilities for much better query experience. And also, using Delta, you can have built-in data expectations. You can specify what's your expectation to this and that columns on the format. And it also has this built-in history. It means you can do time traveling, you can do audit history, and you can pretty much have data version for you automatically there, right? You can always go back to certain versions, and you can always go into the details to see which version have what changes. So all of these are the benefits by having Delta to be your core pillar of your data solutions. So industrial-wide, we are always seeing these kind of ingestion and ETL patterns to be some best practices, right? So very commonly seen across different use cases are what you see here. On the very left, you have all kinds of data sources. Just now we mentioned unstructured, structured, or semi-structured, streaming or batch, right? So if it's streaming data on Azure, usually it comes to like Event Hub or like messaging systems or IoT Hub. And then it will go into Databricks for processing and then to land it into the bronze table. And remember, Delta can process streaming and batch together. So that's why you will have also this batch line here, which can be orchestrated by tools like Azure Data Factory. So together, we are forming this curated data layer. And in this is so-called Lakehouse, right? So once you're ready with all of these tables, you can then consume them from different endpoints. Like you can directly do data science work in Databricks. You can also collaborate with Azure Machine Learning. That's for the ML part. You can also do BI work, right? So for example, by having an additional data warehouse for like dedicated SQL pool in signups to push data in there for like low latency retrieval. Then to connect to Power BI, right? But of course, you can also directly connect Power BI to Lakehouse, to Delta tables, through the SQL endpoint in Databricks SQL or in the normal clusters. So those are the common patterns of the end-to-end picture for the ETL or ingestion pipeline. So data engineering and streaming with Databricks, this is the very first component that we see. So this step describes how you should be creating your curated data layer to create your bronze, silver, and gold layer with all these tools in labeled as green boxes here, right? So let's see from the raw data ingestion part, you have all the data sources ready. Then there are many tools for you to use Databricks more efficiently. For example, autoloader, it can automatically detect the newly ingested files and then to auto ingest that into your Delta tables. You also have these Delta Live tables, which is a relatively new component that enables you to build an automated ETL pipeline with very easy syntax, right? So everything will be automatically tracked in here and auto-resolved for you to save all your operations hassle in building your ETL pipelines. Of course, you will be building your batch and streaming workloads. You can put them together onto the same table. That's no issue. And this will be a proven and consistent pattern for any scale of data solutions. Right? And also in this architecture, definitely for the compute and storage layers is totally separated. So all your data will be stored in your ADLS. Often we have customers asking, where is this Delta table sitting at? So actually all the data can also be stored at your ADLS storage account there, right? So with the knowledge of what Delta Lake is and what Lakehouse is, we're ready to get started with using that, right? So if you are creating a table and you want to start by creating Delta table, the syntax is super similar, very easy. So previously, you can say create table using Parquet, and then also from data frame API, you can just say df write format Parquet, right? So to Delta is exactly the same, just like create table using Delta. In Databricks, all the tables you create, if you don't mention using Delta, will by default be using Delta. And if you use df.write.format Delta, then it will also be writing the Delta format underlying in the underlying data storage there. And you may ask, if I already have some Parquet-based tables, how can I quickly get started, right? It's super easy as well. You can just say convert to Delta and give the path of the table's underlying data, and optionally put in this partition by something of the table structure. Then you can have a Delta table there. So very easy conversions there. And optionally, you can do some optimization on the table after you have done the creation. So you can see the syntax is like optimize the table, and you can do the order by, right? This is further to do some data collocation on the storage level too. So one major benefit for having Delta in place is you can use these observe and merge functions to leverage the ACID transaction capability. You can do merge into your table and to update the records when your records match some keys, or if it doesn't match, you just insert them, right? So this is very crucial for many of the ingestion scenarios. For example, you want to update your certain rows in the existing table in Delta, and that's how easy it is to do an update on the Delta tables. Of course, you can also do time travel by selecting like different timestamps of this table or different versions of it. So pretty much very easy syntax for you to go back to history of that table. And also you can do this rollback accidental bad writes to prevent the data to be corrupted and then to go back to the previous versions as well. So the very next subtopic is on end-to-end machine learning on Databricks. If you see the ecosystem on doing machine learning and data science in Databricks, everything, again, will be built on top of the Lakehouse or the Delta tables, right? So first, we will be having all these bronze, silver, gold tables ready for consumption. then in Databricks, you'll be using notebooks to do the exploration work, to develop your model, and then to train your model using all these clusters. The clusters can mean Spark clusters, can also mean single node clusters. Depends on what machine learning algorithm you are using, whether it's distributed or not, right? You can also leverage HyperOp to train your model in a distributed manner as well. After you have trained the model, it comes to the serving. Then on Azure, there are many ways to serve your model. Of course, you can serve it in batch, in streaming, within Databricks. But if it comes to serving the model on a platform, on a PaaS, then you can leverage Azure's ACI, AML, AKS to do your model serving, right? So these will enable you to create REST API endpoints, so you can shoot JSON payloads towards that and to get the prediction results back. So all of these are the end-to-end pattern that you start by doing all the data engineering work, create the tables, then to use those tables to create your models, and then you'll be serving your models either in Databricks or in other Azure machine learning platforms. So the UI part on Databricks machine learning, you can see that it enables you to choose the ML runtime. So ML runtime is pretty much just the prepackaged environment that have already built in all of these kind of popular ML toolkits and frameworks for you, right? So you don't need to install your own manually there. And also you can use Horovod to run distributed machine learning very easily. We also provide this Databricks built-in auto ML process, so you can throw in a data set and quickly get the prediction power of it, and then to train some models based on your data set. Very easy. So one key component of Databricks machine learning is the managed ML flow, right? So we'll be using ML flow to do all the machine learning development and model tracking and model registry stuff. So all of these are the components within ML flow. And again, ML flow incorporate with all like major machine learning frameworks, like what you have seen here, right? It comes in different flavors. And then your data scientist can come and then do your training. In the process, they will be tracking a lot of artifacts, like the model themselves, the performance metrics, and all the metadata parameters, metrics, everything that they can do in the training process, they can track within the ML flow. So after it has been tracked, it's time to deploy the model into model registry. This is to have a dedicated place to register and manage your life cycle of the models you train. And after that, you can put it into deployment platforms like listed here. So if we see the high-level view on Databricks machine learning, this will be a data-native and collaborative solution for the full ML lifecycle. Right? From the bottom, the foundation will still be Lakehouse and the feature store. Then you'll be creating all your models on all of these foundations, right? And then to build your model serving layers. And on top of it, the interface that users use will be the collaborative multi-language notebooks. Collaborative means that you can have multiple users on the same notebook as well to edit it together, right? So the collaborative scenario could come like that. You can have data engineers, data scientists, or machine learning engineers using collaborative notebooks. And it can also show your code presence, as you can see here, right? And obviously, you can see ML flow model tracking very easily from the UI. We'll be looking at the details very soon. Then the end-to-end view really looks like that. Right? So from data preparation, data engineering, all the way to feature engineering, and the model development and model serving. So everything here will be looped through this model ops, this ML ops lifecycle here, and you can use a lot of tools to build your own ML ops pipeline and framework. And to zoom in further, having an ML ops solution means you should be tracking your data in your like data ops kind of concept. This is automatically done using Delta Lake, right? You have the data versioning, quality control, feature store automatically within Databricks. You should also have some DevOps, means you should check in your code frequently to do the merge the pull request as well. So Databricks has this feature called Databricks repos. On the UI, you will see that it enables you to link to major version control system, VCS, or for example, Azure DevOps, GitHub, Bitbucket, right? So this enables you to do all the management on the code perspective. Also, it should also include this model ops, means everything that you train, you get from the training process should also be tracked. This is also being taken care of by having the managed ML flow to do your lifecycle management on model registry, and you can easily reproduce all the runs and then to do some CI/CD pipeline integration within the platform, right? So this is pretty much just saying that you can use Horovod Runner for some distributed model training very easily within Databricks. Right? And then you can have this hyperparameter tuning visualized for you in a manner. So how we usually use this chart is you can have a coarse tuning first, and then to see which region will be more interested for you to look further. And then you can tune your parameter grid again and to focus on those regions to train again, right? So pretty much that's a value provided by having a visualized way on your parameter grid. Some of the new features on Databricks ML includes cloudless integration is already there from DBR, Databricks Runtime 10 onwards. So using these, you can seamlessly using more or less Pandas API, but underlyingly is pretty much using the Spark data frames, right? So pretty much using the cloudless library there. Then this is also this is built-in model serving within Databricks. Later on, we'll see a detailed demo on that. So you can create a development-ready REST API endpoint that you can test your deployed model, your packaged model, and then to shoot your JSON payloads towards it. Right? AutoML. So AutoML is also there for very quickly going through your data sets, right? And to see whether the data sets have prediction power or not. What this can do is you can throw in a data set and then to let Databricks to train for you and to loop through all the kind of machine learning frameworks, and then it will select the best one for you. We will call this as a glass box approach because what underlying is happening is Databricks is generating all these notebooks for you. Instead of giving a already trained model as a black box, you don't know what's happening there. We're actually generating all the code for you. So this means a lot because you can immediately take the code and then do further development on top of it. Right? AutoML also gives you this data exploration notebook, which does all the statistics for you and then saves the hassle for data scientists to go in and run the stats by themselves. Right? And using this Glassbox AutoML is also very simple, just a few steps. First, you need to configure what data set you want to try, and then you just need to say, okay, whether I want it to be run for 4 hours or 2 hours, and select the best one. It's like train and evaluate. Select your target column to train. Then you can customize your code and then further deploy the model within Databricks. Right? Some additional things on the feature store. So feature store is also co-designed with Delta Lake. Right? So this is a dedicated place for data scientists to create the features in a reusable manner and then to share it with other teams or other colleagues within the team. And by having a dedicated feature store, it means that you can register your features into this place called feature registry. Then in terms of serving, it also have two flavors. One is in batch for high throughput scenarios. One is online for low latency. In low latency, you will need to provide a kind of database, kind of platform to host all of those informations. Right? So what feature store brings to you are many benefits. The first one is the lineage. Now you can see what data source created this feature and what models or what notebooks or what endpoints are consuming from these features tables. Then, so these slides pretty much talks about how we can design a centralized model registry with MLflow. So this more applies for some CI/CD controls on separating different workspaces for production, development, and staging. Right? All of these can actually be sharing a centralized model registry for with one of the workspace. Right? So you can pretty much register your models together into that registry, but you can do your code in different places in the distributed way. Also, here are some keywords for you to search. Those are relatively more important features that Databricks ML can provide to the table. Right. So with that, we are on time for the second part, which is on demo. All right, so in the first 5 minutes, we'll be taking a very brief tour on the Databricks workspace. Now you should be seeing my landing page for my demo workspace here. So the very first thing is within the workspace, here are 3 tabs, right? So the 3 tabs corresponding to the 3 major data personas that we mentioned previously: the data engineering, and data science, and machine learning, and SQL for BI users, right? If we go through one by one, data science and engineering, it consists of all of these components. If we go to machine learning, pretty much you just have 3 actual tabs for you. And then if we go to Databricks SQL, that will be a totally different a totally different place. It's a dedicated place for Spark SQL workloads. Right? So you can see things have changed quite a lot. So let's go back to the first one. You can see here are some. The very first thing we can see is a compute tab. So here you can create all your compute resources within Databricks. So for example, if we do like that, I can choose all of this mode. I can also choose single node cluster as well. So then here I'm choosing Databricks runtime. And then here you can see runtimes are either standard or ML. So for ML, it means it has some pre-built package in there, so you don't need to install your own libraries again. And under ML, you can see we also have GPU support for your distributed machine learning or deep learning use cases. You can see here there's a Photon. So Photon is pretty much an engine that's compatible with Spark. So when you turn on Photon, it will be much faster in terms of computation. And this is super beneficial for ETL workloads that runs very long time. And when you turn it on, the total cost will actually go down because the speed will be much faster than without the Photon engine. Right? And notice that with Photon, only a few Databricks runtime supports Photon. And currently, this will be a preview in the preview mode. Right? You can also, for example, I choose a standard mode. I can also choose how many number of workers I want to have within this cluster and what type of workers, the instance type or the node size that I want to choose here. Right? Then you can also enable auto-scaling to specify this min and max. If I don't choose that, it goes back to this. I can also choose this idle time. If I don't do anything within 120 minutes, it will be terminated. Right? Advanced options, it can do some additional configuration for you. And just now, repos is a place that you can connect to your version control system, your GitHub, your Azure DevOps, repos, all those things, right? And workflows is a place that you can automate your job and then to create all your automated pipelines to run in a scheduled manner or a triggered manner. So under the workflow, you now will have majorly 2 components. One is jobs, the other is Delta Live table. So one thing on the jobs I need to mention is now job clusters can be reused. Means, for example, I choose this task, I can just select any random notebooks here. And for example, if I create a new job cluster here, this will be my first task in this job, right? And then I can choose my second task. Again, I can choose another notebook. Yeah. Then you can see now I'm able to use test1 cluster. That's a job cluster I created just now. So this is called job cluster reuse, and it immediately saves you cost, right? And then you can see some dependencies here. If I create this one, it will have some dependencies built in here. So within Databricks, you can do all these kind of workflow designs to create your pipelines very easily. And then you can just do triggered run now, something like that. Of course, everything you see here, we have API under the hood. So you can trigger it programmatically, no problem, right? So under the machine learning, you will have some extra tabs. One is experiment. So all of these will be the ML flow triggered experiment tracking. Means if you have initiated an ML flow experiment, it will be stored here, right? And also feature store will be the dedicated place for you to save all of those features. Models will be the model registry that you can register your trained models. So that's pretty much a brief tour on the first 5 minutes. Then the next one we're looking at is how to use streaming workload with Delta tables. So if we go to today's content one, this notebook one here, it shows you how to do the auto ingestion using autoloader, right? So my scenario here is I have a storage account pre-configured here, and for development purposes and quick demo, I'll just directly use the key to configure my Spark session. This is to enable Spark to be able to read and write to that storage account. So in this example, we'll be seeing how to ingest JSON files into the cloud storage container, and then using the autoloader to move those into a Delta table automatically. So just creating some widget here. These are like parameters like that. Then in the storage here, let's just create a destination first, right? I'll call it sync 1, sync 2, and sync 3. So I have 3 containers here called sync 1, 2, 3. I also have these container called autoloader stores, where I will be putting in some JSON file to simulate this streaming event, right? So I can start running these scripts here. Pretty much is using this format called cloud files. Once you see that, that means you are using autoloader, built-in autoloader here. Then we're just reading this whole thing in as a data frame, and then we'll be transforming the data frame by adding a new column, and then to write it out as a Delta table. Right? So pretty much we can start the streaming job. And now you can see the streaming job has been started. I just need to upload. For example, I just upload 3 JSON files here. And then this will trigger an automated ingestion to the sync, right? Just now I specify sync 1. So sync 1 will be here. You can see I've already see the values being ingested here. If I go back to here, I load the sync 1's data back, and automatically I can see that all of these are ingested to my underlying table data. Right? You can see it's automatically ingested. So some additional components are, you can use the function called for each batch to process each micro batch and update its Delta files. Right? So similar as before, but now we're creating more modifications by using a function. Right? You can also see I'm caching the first DF, and then do multiple transformations, and then to write it out to different locations. This is important, right? So let me go back to here. I can also simulate, for example, I'll just remove this array first. I only have 3 sample files for today. And if I go back to this one, I'm already triggering my event is listening to that container. So if I just also upload again, yeah, so this will trigger the Spark job as well, right? So this is good for any complex logic that you want to do using a wrapper and put it into this for each batch function. So pretty much you can see I passed in a function here, and in the function I will define all the complex logic that I want, right? So if I just read it back, and then I can see successfully I have written out this new modification that I processed. So you can see I'm also writing out to different locations as well from the same function. So that's very convenient. Then you can also have a little bit more complicated logic like that to do some observes. Right? So again, let me just remove these. So everything here I do is to simulate a streaming event. Right? And what this does is pretty much using this aggregate table to merge into this aggregates table. Right? So this is to do some updates. You can also see that we have defined the updates logic within a function called observed to delta, and we have pushed this function to this for each batch. So very easily you can do the updates here, right? So that's how convenient it is to work with streaming workload with Delta tables. And remember, if you are doing it by yourself, you should also like stop all the streams after it's done, right? Otherwise, your cluster will not be like auto-terminated. It's still considered a running job. So that completes our second demo. The third demo will be on Event Hub integration. So let's go to the Event Hub demo here. So what this demo shows you is how do you do like some encryption on your data. For example, if you have a JSON payload and you want to encrypt it, and then to send it to Event Hub, and also to receive from Event Hub, and then to do some decryption. So this example, if you have configured your Event Hub and Azure Keyboard successfully, you should be able to run this very smoothly by yourself in your environment. Right? You just need to follow the instruction in detail here. Again, let's read this together. We're using the symmetric encryption. What does that mean? That means you are using the same key for encryption and decryption, and then to encrypt selected attribute in your JSON payload, right? We're only using partial encryption for imagining you are encrypting PII information only. And then we'll be writing the payloads from your Spark data frame directly to your Event Hub, from Databricks to Event Hub. And then you'll also be receiving from Event Hub to your Spark data frame. So we're simulating the whole flow here, right? From sending to receiving, encryption to decryption. So let's see what we're doing here. First of all, some simple UDF, this is for encryption purposes. And then also some helper functions here. What this does is pretty much create a wrapper to very conveniently write your data frame to Event Hub, right? I just need to pass in the data frame and the connection string of your Event Hub, then I can very easily write it to my Event Hub namespace. And here I'm also using some randomly generated payloads. Like you can see my payload will only have two keys. One is a so-called sensitive key. Let's pretend this is PII. And then I'll have a age attribute. It's a random value, right? This will also be a random value as well. Data on yours. Event Hub integration, you just need to follow the Azure Databricks official documentation to see how it should be configured. But you can also use this as a quick starter example, right? You will have a PySpark version. You will also have Scala version, sample code. So start reading from Event Hub. I just need to do like .format Event Hub and options. I'll put my Event Hub connection string there. Then I can, let me always listen into that Event Hub. Then this function is pretty much just to decode the information from Event Hub. Because everything you get from Event Hub is actually an encoded binary kind of string there. So that's why you always need this kind of thing to do a decoding first. Note that we haven't sent anything to Event Hub now. We're just pretending we're listening to that Event Hub, but we haven't sent any message to that thing yet. Then we'll be doing some manipulations on the data frames like that, and then to make it as the data frame to be displayed to you, right? Then further, we'll be using this UDF to decrypt the message that we have encrypted in the very beginning. Now, this is an important step, the last one. So only at this step, we are sending data towards Event Hub. So now I have triggered it once, means I have sent one randomly generated row or the JSON payload to Event Hub. So let's observe what will happen here. So now Event Hub will actually go ahead and encrypt the thing, encode the thing and into the body, which is here, where I will be using that and then to decode it. So this is after the decoding from Event Hub. But you can see this is still encrypted by my fernet key, right, the name. So here, and everything I didn't run anything is automatically chained up together. You can see now I have successfully decrypted the message here, right, using this clear text name. And then if I write more, so now you can see my point of simulating this as a, for example, streaming event happening in multiple times. So you can see that it's actually very fast. One by one, it comes into the pipeline and go out of the pipeline there. So very fun examples to play with. I encourage you to try yourself. You can see that how this can be done there. Right? Note that we often get requests on the encryption with Event Hubs. Usually, if you search that on Google, that will lead you to Event Hub's internal encryption. That just means you can, for example, using your own customer key to encrypt, to let Event Hub to encrypt the message while the message is inside the Event Hub. It's not saying we are encrypting the message for you, right? So what we're doing it here using a fernet key is the real part of encryption, right? So be clear on what's decoding and what's decrypting. Right? Be different. Again, many requests have been submitted, many messages have been sent. To stop all the streams here. So I hope this is clear on the Event Hub integration. Next one, we'll be looking at ADF. Right? So ADF is relatively easy because in ADF, you already have these Databricks activities. So all of these are called the native activities within ADF. So within that, you can link your data factory to a Databricks linked service. You just need to have this. And then in the setting, you can provide your parameter, and you need to specify what notebook will be run in the notebook activity, right? Same as before. You can also do jar and Python activity. However, there's some more practices of using ADF, which you can use web activity to trigger things from API perspective. Why we're doing that is because you can see the native ones doesn't have Databricks jobs, right? So some of the things that are more complicated can only be run through the web activity. For example, here I'm using my URL to the as the API endpoint and specify this one, and then I can pretty much trigger it now, right? What this does is just to list out the available jobs in this workspace for me, and then to put it into this variable. That's it. Right? So I've already run it. Okay, it's already run there very quick because it's just an API call. You can already see that in the output here, I have already got all these API payloads results. Right? So you can see very clearly what are these. So this is one thing that you can use to orchestrate Databricks jobs within ADF, that's so-called ADF integration. Just now we've mentioned that in Databricks, we have this workflow, right? So workflow, you have jobs and Delta live tables. You can pretty much do like a lot of orchestration here. So these are like parallel to Data Factory. You can choose either of them. Or if you have very complicated things to manage, you can choose a hybrid version, right? By using a web activity, then you can do anything in Databricks. So hope that is clear on ADF integration. Next one we're seeing is machine learning, right? If we go back to here, we're on the machine learning tab. And let's go to this one. And we'll go to the third notebook here. So this notebook tells you how to use manage ML flow for all kinds of stuff, right? Again, as usual, to create your widget, this is your parameter. First of all, we'll be downloading some sample data set with wine quality red, and then to copy that to a DBFS location. Then we can show that, okay, it works. We can show a pandas data frame, right? So for example, this is using CSV files. And then you can create your ML flow run to train your model and save it as a Elastic Next model or any other framework that you're using to predict wine ratings. So again, here I can also define an input example that's very convenient for future use. Then I'll be define my train function here. So whenever I call this one, it will trigger a train with MLflow start run here. So let's just create a function first. And then at this stage, I'll just call train, right? I'll just call train. Then I can print my model URI. This is the location where you should be looking at for your model artifacts. Then I can also register that to the model registry. It says that I've already registered that previously, so it's creating a new version. And then all the models you registered are actually stored in this model tab. So in the model tab, you can see here, this is the model I just registered for a new version. This is the new, like today's state just now, and it's have no text yet, right? So I can push this one, I can go into this one, and then to do some transition. And also I can request for transition to something. Because, for example, I'm a data scientist, and then I have trained my model here. I want to move this model to production. Then I need someone to come in and say approve, right? You can also do this programmatically, say that, okay, I can just use this one, and then if I refresh that, it actually goes through staging. So I've programmatically triggered that through the MLflow client in Notebook and push this into here. You can also see all the activity logs here and all the approver information as well. So if we go back to the experiment just now, you see I did this MLflow simple demo, and it have all these two runs here. I can go to any of them, and I can see that, okay, all these are the artifacts being tracked here, right? So everything that you do in code can be tracked here. Then it also says how to use this one to make it for prediction. Very handy for you to use. Just now we talk about model serving. So if we go back to here, into a register the model, you can see a serving option. You go to here, and you can enable serving. What this does is to create a single node cluster at the back end for you. You can see from the compute job clusters. So there will be a single node cluster created for you for this model to be served. Right? And then after probably 2 minutes, it will be ready, and then you can shoot for example, show some examples. This is an example you show in the code, and you can send the request. It will return you the response. Right? Running a bit low on time. Let's go back to the experiments. I want to show you what AutoML is. So AutoML, you can just create this AutoML experiment here, and you can just supply your cluster and then choose your problem type. Classification, regression, for time series forecasting. Classification, for example, and then choose your data set. E.g., right? I'll just choose this like simple data set here. It will prompt you to see which target you want. For example, I want to have this churn stream. Then you give it the name, and then you can optionally specify all kinds of training frameworks that you want to loop through. These are all the supported ones for now, and give it a duration, right? Stopping conditions. And then you can start AutoML experiment. So once this is done, it will lead you to this process. So later, you'll be seeing all the kind of things being automatically generated for you. To make it easier, previously I have run something. And, sorry, not this one. Yeah, this one. So this one. So after you have done the auto training, you will have all the different notebooks generated for you, and you can go into any one of it. So all of these are machine generated code, right? Machine generated code. That's what we call a glass box approach. So you can further take this one and then to do additional development, and then to modify your pipeline of training and to create your own models, right? Okay, that's pretty much about machine learning. Like 3 minutes for Databricks SQL. We go to here. So again, as we said, Databricks SQL is a dedicated place for Spark SQL workload. The compute resource used here are called SQL endpoints. So if you are trying to create a SQL endpoint, you will see that all these are like t-shirt size, right? So SQL endpoint is nothing but just a load balancer with a few Spark clusters at the back end. And then it handles concurrent queries better than the normal clusters because it will scale by adding in more and more clusters. So the scaling is very different to normal clusters, because SQL endpoint is scaling up by adding more clusters. But for normal clusters, it scales up by adding workers, right? So different levels, different hierarchy. Then you can also do like auto scaling, auto stop as usual, right? Then you can see this is a dedicated place for you to run SQL, Spark SQL. Pretty much you can also save your query and then to do a bunch of the BIs here. Additionally, you can see this partner connecting, right? If you go into here, you will find a lot of solutions here. And if I click Power BI, I can choose which SQL endpoint I want to connect to. Then I can download my connection file. So connection file is nothing but just some JSON files. And then you still need to sign in via Azure AD on your Power BI to get authenticated and then to connect to your SQL endpoint for consumption, right? So for SQL endpoint, it's pretty much a good place for all your Spark SQL workload, and this will be like the fastest and the most economic way for your Spark SQL workload. Because Photon there's no additional charge on DBU for Photon in SQL endpoint. Yeah, but for normal clusters, there will be. Okay, so we are pretty much barely on time on this session for 1 hour. Again, you can take a screenshot or probably see from the QA channel on these demo notebooks used for today. We have gone through pretty much quite a lot of things here. I know like we went pretty fast. You may have not catched up with the speed, but I do encourage you to look at all these notebooks and then to do experiments on yourself, right, in your own experiment. If you don't have an environment, you can get a free Azure Pass for like $200 there from Azure, and then to do your experiments from that test account there, right? Okay, then that's pretty much it. And I'm not sure whether there's like feedback portion on this one. If there is, please, we really appreciate your feedback for this kind of session. It helps us to organize the topics for future events as well. And thanks a lot for your time today. And looking forward to seeing you next time. And thanks to JK and Joey for hosting the event Q&A.